Hello, you're welcome to my channel. Now here we're going to talk about the example 2 under a fraction with linear factors. So how to decompose a fraction with linear factors, the example 2, alright? So if you haven't watched the example 1 or neither have you watched the introduction to partial fractions, please, I want you to go back and check that out before you come over here, alright? Because there are some important things you need to know, alright? Of which I will not talk about it here again. Okay, so for example 2, we have 2x plus 5 over x squared minus 10x plus 9. The first thing I would like to ask you is this fraction a proper fraction? So, what I told you on the other videos, okay, especially the introduction to partial fractions, I said that for a fraction to be a partial fraction, okay, given that the numerator and denominator are all polynomial functions, then for a fraction to be proper, the degree of the numerator should be less than the degree of the denominator. So if you see, the degree of the numerator is just 1, but the degree of the denominator is just 2. So the numerator is a linear polynomial and the denominator is a quadratic polynomial. So that is just it. So that means that is a proper fraction, so we can make use of that. And the next thing I would like to do here is to talk about the factors of this denominator, okay? Well, the denominator here is the same as the one we did on the first example. So I'm just making use of this so that I don't want to go back to factorizing this again. Okay, so we knew that the factors of this denominator are, we know that x squared minus 10x plus 9 is the same thing as x minus 1 times x minus 9, right? We just want to multiply this, x squared minus 9x minus x plus 9. So that is just it. Minus 9x minus x will give you negative 10x. So this is a product of two linear factors, okay? So this is a factor and this also is a factor. So by what we learned, we said we can do this. We can add this, okay? This is a blank line. This is just division, okay? So the first fraction, we put down one of the factors. The next, we put down the other factor. Now, here's a question for you. You recall that in the first example, we were using 1 on top, right? It was not 2x plus 5. It was just 1, which means that the degree there was 0. But here we are using 2x plus 5. Are we going to still write a and b? Yes, we will still write a and b, provided that this right here is a linear factor and this right here is also a linear factor. Remember that I said we are going to decompose this into partial fractions where the degree of the numerator of each of the fractions will be 1 less than the degree of the denominator for each of the fractions, so as many as it will be. Like this one, when we come over here, we will see that. Okay, so I will write here a. So since the degree is 1, the degree should be 1 less than 1, which is 0, alright? Well, that means it's just going to give us a constant 10. And here I'm going to write this as b. A and b may not be equal. So it just depends on what we get after solving, okay? So this right here is for you. Again, I would like to solve this using the cover-up method, alright? But know that the result, the value of a and b will not be the same. Even when these have the same factors, it will not be the same because the numerators here are different. So, a and b, okay? So let's look at this. By cover-up method. So, as always, which value of x will make this first fraction to be undefined? That is to say, which value of x will make the denominator of this first fraction to be 0? Okay, when the denominator of the fraction is 0, then the fraction is going to be undefined. So the denominator here will be 0 if x is 1. So I didn't write this out. Okay, let me just write this out quickly. 2x plus 5 over x minus 1 times x minus 9, okay, and I'm writing this as x minus 1 plus b over x minus 9, alright? Okay, so this denominator is the same thing as this. It's just these are just factors of this one. So I'm saying which value of x will make this first fraction to be undefined, that is 1. So I'm going to cover up that factor, x minus 1, okay, and plug in that 1 into the other factor. That will be 1 minus 9 that is negative 8 in the denominator, right? And at the top, we plug in 1 for x. We're going to have 2 times 1, that will be 2, plus 5, that is just 7, right? So a will be equal to 7 divided by negative 8, that is just negative 7 over 8. That is the value of a. Okay, negative 7 over 8, I'll write it out actually. The next thing is for the value of b, alright? Let me clean this. So to solve for b, we look at this denominator, x minus 9 equal to 0. That means x will be equal to 9, okay? So we go ahead and have x minus 9 equals to 0. That is, we equate the denominator to 0. We solve for x. So we add 9 to both sides, x will be equal to 9. You come here, cover up that factor, x minus 9, substitute that 9 into the other factor, that will be x minus 9, you cover that, then x minus 1, you plug in 9 for x, you're going to have 9 minus 1, that is just 8 in the denominator. You go again and plug in 9 for x at the top there, you're going to have 2 times 9, that is just going to be 18, alright? And 18 plus 5, that is 23. So you have 23 on the top and you have 8 on the bottom. So b is equal to 23 over 8. All in all, we're going to see that this fraction 2x plus 5 divided by x squared minus 10x plus 9 is equal to negative 7 over, like we did the other time, okay? Don't waste time to put it on top like that. Just put this 8 down here and multiply it with this one, x minus 1. So you substitute negative 7 over x in place, negative 7 over 8 in place of a, alright? So this is what you just get, negative 7 over 8. Then that 8 can come down like this. You add it with 23 over 8 times x minus 9. And this sum of two fractions here is a partial fraction decomposition of that. Okay. Alright, over to the next video. Let's solve the third question. And please make sure you subscribe to my channel.